Great. So we have deploying to staging. Now we can add deploy to production. But before we add this step of deploying to production environment, let's do one optimization to our pipeline code. As you probably already noticed, these two jobs, deploy to dev and deploy to staging, have almost identical logic. So if we add the deploy to production job with the same logic, we will be repeating the code 3 times, which is not clean and it makes the pipeline configuration hard to read and maintain. So let's follow the best practice of writing GitLab CI/CD pipeline configuration and clean up this code duplication. So the question is, how do we reuse the code inside GitLab CI/CD configuration? Well, for that we have another concept called extends, and it's pretty simple actually. So we take the code or configuration that repeats, in which case it is actually the whole thing, because we basically just took and copied the whole thing and just set some parameters. So we take this whole thing, and I'm gonna cut out that, and we create a generic base job from it. And let's call this job deploy. And this one will have the generic deploy logic. So now this is specific to development, obviously, because we have those values here. So we're gonna make this logic generic so it can be reused by different deploy jobs. First of all, let's remove the stage. So this can be defined by the specific deploy jobs. Since we're using the same GitLab runner, we can leave the tag, which all 3 will share. And there are 2 or 3 values that are actually different between the jobs that we use inside the script logic. So whenever we extend the generic job, we would need to pass those values for the specific deployment job. And we do that using environment variables. So SSH private key will be different for each deployment, especially if we are like in real life using different machines. The server host will be different, the application port will be different, and project name will be different. So these 4 values will be different for the specific jobs. So let's define them as variables right here. So SSH private key will be passed from the specific job. Then we have the server host, so we can make this generic and rename it to the server host like this. So this will be passed as a variable value. Then we have the compose project name, the value of which will be the environment. So let's call this environment or deploy environment. And this should be set from outside. By default, it's empty. The port, let's call it app port. And right here, we also have 2 additional values. Let's actually reuse that deploy env right here and call this endpoint, which should also be passed from outside. So we have 5 variables or 5 parameters in total that should be set to make this generic job into a specific deployment job. So right now, everything is parameterized. This is generic, customizable, nothing is hard-coded here. So we can reuse this base job and all this logic basically in the specific deploy jobs. So how do we do that? Super simple. We have a keyword called extends that specifies whatever job we want to extend. So it's like creating a hierarchy of the jobs. So we have a job and everything defined here will be inherited by whichever job extends it, right? We also said that we're gonna specify a stage for each job, deploy dev. And of course we have to pass the values for all those variables. So I'm going to copy them and let's define variables list and let's set those values one by one. First of all, we have the SSH private key that the base job deploy expects, and we have an environment variable which we created ourselves, so we can reference it here. Note that this environment variable can be named something different. It doesn't have to be the same. Then we have the server host, which is going to be the dev server host. Then we have deploy environment, which is development. App port is 3000 and endpoint is dev endpoint. That's it. So by extending the base deploy job, we're reusing everything that we have defined here in the deploy to dev job, and everything that is different or needs to be specific to the dev deployment, we are setting them using environment variables. And now let's do the same for the staging. I'm going to copy all of this. Let's remove the whole logic and extend the deploy job. Then we're deploying to staging. And let's set the variables. The SSH private key in this case is going to be the same. Then server host is going to be staging server host. The deploy environment will be staging. Port will be 4000. And endpoint will be staging endpoint. I think that's what we called it. There you go. So now instead of having this whole code twice or 3 times, we have extracted it into a generic job, and we're just extending it or implementing it specifically by just setting a couple of variables, and that's it. Now, you're probably thinking, when we run this, we actually have an additional job, deploy. This is also going to get executed. So we have a deploy job that basically has no values for those parameters, so it's going to fail. So how does that work? So we need this job just as the base so that we can extend from it in deploy to dev, deploy to staging, and deploy to production. We don't want this job to get executed as a separate job because, again, we don't have any values here. This is just the base default thing. So how do we prevent this job from being executed? Well, we make it inactive. In GitLab CI/CD, you can make jobs inactive by making them what's called hidden jobs. And the syntax for that is simply dot before the job name. That's it. So when GitLab sees there's a job here that starts with dot in the name, it knows this is a job that is supposed to be extended. It's not supposed to be executed. And of course, in the extends value, we have to use that dot as well. And that's it. So this will prevent deploy to be executed as a separate job, and the problem will be solved. And now we can easily add a deploy to production job without repeating this whole code. Instead, just defining this couple of lines. So let's call these production, or deploy to prod for short. Deploy prod. So we're going to make a new stage for that. And the same way, let's actually simulate running performance tests after we deploy to the staging. So let's do run performance tests. And we have a script here that just echoes running performance tests. It will run in the deploy staging stage, and it will have a dependency on this job. So this job should run only after we have deployed staging, because theoretically these tests will run on the staging environment or against the application version on the staging environment. That's why it makes sense to wait for the deployment to staging before we execute the tests. If the performance tests are not successful, if they fail, we don't want to deploy to prod. If they are successful, we can deploy to prod. And let's set those values as well. The SSH private key will be the same. The staging will be the same. Let's create environment variables for the production. Let's call them prod, server host, prod endpoint. And again, in this case, we have the same machine, but in real life, this will be different. So we need a separate variable for that. And prod endpoint will have port 5000 at the end. And again, this whole URL will also be different in a real life use case. So we're not gonna extract it and reuse it. So we're gonna leave it like this. Let's copy that. Prod server host, Let's call it production, port 5000, staging endpoint, so that we have prod endpoint. Awesome. So we have 3 deployment jobs that all extend from the base deploy so that we don't repeat the same code over and over again and make our pipeline configuration cleaner. Now there's one thing we want to add to production deployment that we don't have on the other 2 deployment jobs. Usually in real life projects, even after extensive testing, many teams do not feel comfortable deploying to the production automatically without any manual human review before the deployment. So usually the pipeline will go all the way to staging and run the tests, but it won't deploy to production automatically. Instead, it will wait for a human user input, like just clicking a button saying deploy, and we can configure that very simply in GitLab using an attribute called when and the value called manual. So this will tell GitLab, do not execute this job immediately, wait for a user input. So this job is supposed to be executed with a manual approval. We have one final issue with this configuration, and that is specific to a variable of file type. Remember that we created this SSH private key variable as a file type variable, right? And you also remember when we echoed the variable value, this actually gives us a path to a temporary file which has the contents of this SSH private key. So this gives us the location of the file on the GitLab runner server. And we're passing that value, whatever that variable value is, to another variable which we also called SSH private key. This could be SSH key, it doesn't really matter. In this case, we just keep it the same. And this seems to be a bug in GitLab. Variable contains content of file instead of the file path. And this is an issue that a lot of people have, and maybe it gets fixed in the future, but it is a known bug. So what happens here is that whenever you pass a value of file type variable to another variable in your pipeline, instead of the path of the file, the content of the file gets assigned. So the value of this will not be the location of the file, which is what we need. Instead, it's going to be the whole content, this private key certificate content, and not the file path. And this will actually give us an error because in these commands, we need a file path. This is not going to accept the contents. It's just going to give you an error that says it's an invalid value or not recognizable or whatever. So we actually need the file path and not the contents. So we need to fix that or kind of work around this GitLab bug. So first of all, to avoid any confusion, let's rename this variable that our base deploy job accepts. So this one here to SSH key, right? So we're passing an SSH key variable in all the deploy jobs. And inside this deploy job, SSH key, as I mentioned, will reference the file contents. So what we're going to do is we're going to create a file here using those file contents. So we're going to echo those file contents and we're going to pipe it or save it into a file. And let's call it deploykey.pem. So that's the file extension we're using. And then we're going to use that file in all these different places where we need the file and not the contents. So that's going to be our workaround. So right here, we're going to do deploykey.pem and the same in these 2 commands. So we're getting the file contents instead of the file path passed to our deploy job, and then we're converting those contents back into a file. So this will save the contents of the SSH key into the PEM file, this new file that we're creating, but we need to do a little bit of transformation of that contents in order to save it as a valid format of the PEM file. I promise the final issue that we're going to fix now is that the contents of this file variable will be provided as a one-line content, so to say, one-line value. So SSH private key is a multi-line file, we have the first line, and we have these multiple 64-bit lines, and then we have this final line that says end RSA private key. So we need to transform the one-line value of this file back to multi-line. So we need to do this kind of transformation. And to give you an example of what the variable value will look like, so this is SSH private key, the variable name. The reference is the temporary file. And when we assign it to SSH key variable, then we get the contents, but as a one line. And you see here that instead of a new line, there is just space here. So instead of spaces, we want new lines. We can't do a simple replace space with new line here because we have spaces, unfortunately, here as well and at the end. So we need a little bit more advanced transformation. So let's go back to our code and see what that transformation code will look like. So right here, we're going to pipe this. So the one line value, we're going to use a Linux command called sed, which stands for stream editor. So we're editing that variable value, and we're going to do 3 different edits. So the first one will be to basically keep this begin RSA private key as one line and then do a line break afterwards. And that's going to look like this. So we're basically keeping this whole string, and then we're adding a new line after it instead of the space. So that's one thing. Then we have another transformation that is basically the same, but for the end of the line, which is end RSA private key. We're doing the same here. And then we have all the lines in between. So for those lines, we want to have them on separate lines, and instead of space character, we want new line characters at the end. And that transformation will look like this. So we have these 64 character strings basically. So each one of those lines has 64 characters, and at the end of them, we are adding this new line, right? /n is a character for new line. And you can check out the documentation of this sed command or stream editor command if you want to know exactly what these values mean. But in our case, this transformation should give us exactly what we want, which is from one line value of this variable, we're going to get this format that we see here, which is a valid private key format. So that's the last part of our configuration. And that was really the last issue that we had. And with this, we have completed our configuration. Let's not forget to fix this functional test job and set it back to echo, because we want to make sure the pipeline goes through. And now let's actually make a change in our application code to validate that the changes in the application gets deployed all the way to the production. And let's add here GitLab auto DevOps. And now let's go ahead and commit all those changes and see the result. So add deploy to production. Git push. So before the pipeline actually deploys to the development, we need to stop the container first because we changed the name of the container. So it will not be able to stop the currently running one. So the compose project name, deploy env, we changed it to development instead of dev. So we would need to fix that by removing the container first. So let's do docker stop the container ID. We can leave the staging because we didn't change that one. It's still called staging. So now our pipeline should actually go through. And if we check our pipeline execution, it looks like it went through without a problem. We have the deploy dev that passed and deploy staging that passed, and the deploy prod is basically waiting for a manual approval or manual execution. So let's first of all check the dev and staging deployments and make sure that our change was deployed. So if we refresh right there, we should see the change. Same on the staging. There you go. And right now, if we try to access the prod environment on port 5000, there is nothing deployed there yet. This is the first time deploying to the production environment, and we have to manually trigger it. So at this point, testers, project managers, whoever is responsible for the final decision to release to prod, will basically check the application, will go through the test reports maybe and see that everything is fine. We'll see that performance tests have passed, and they may decide to deploy to the production. And when we have this manual step or manual approval attribute set on a job, you get this play button here, or play icon, that lets you manually trigger it. So this is equivalent to the general play button, which will let you trigger the whole pipeline again. And this is just for that specific job. So let's actually deploy. And you have the same thing on the list view right here, run manual or delayed jobs. And you can run this deploy prod like this. Let's go inside the pipeline and let's actually trigger this play button. And deploy prod was also successful. Now, if we refresh this, we should see the application deployed to production as well on port 5000. And now we have an optimized pipeline that is very close to the real life project pipelines with all the steps in between. So we have the test stage before we even build the application that basically checks and analyzes the code for security and functionality, the unit tests. Then we're building and pushing the image, deploying to dev, running tests on that, deploying to staging, running tests on that, and then manually deploying to the production. Of course, there are some additional steps to make it even more production ready and closer to the real life pipeline, but this is actually a very good foundation of how a pipeline should look like. Till now, we have learned all the main concepts of GitLab CI/CD, and we built a complete CI/CD pipeline for our demo Node.js application. Now let's take this one level up and see how to configure a CI/CD pipeline for a microservices application. Now, why is that important? Microservices have become the standard for modern cloud applications, and a lot of projects that you'll be working on and configuring CI/CD pipelines for will be microservices applications. So it's important to know how to use GitLab CI/CD platform to build pipelines for microservices applications, because there are some specific differences and best practices here compared to building pipeline for a single non-microservice application like my demo Node.js application. And that's exactly what we're gonna learn in this chapter. We will learn how to configure a CI/CD pipeline for a microservices application. So first of all, let's quickly learn what is a microservices application exactly, or if you already know it, you can review and refresh your knowledge. Before microservices, the standard way of developing applications was with a monolithic architecture. This means all the components of the application, the whole code basically is part of a single unit. For example, if we had an online shop application, all of its parts like the user authentication, shopping cart, product catalog, sales campaigns, notification, and so on, all the code for these functionalities would be in one code base as part of one monolithic application. Everything is developed, deployed, and scaled as one unit. This means the application must be written in a single language with one technology stack with a single runtime. And if you have different teams working on different parts of the application, they will need to coordinate to make sure they don't affect each other's work. Also, if developers change code for the payment functionality, you would need to build the whole application and deploy it as one package. You can't just update and deploy only the payment functionality changes separately. So this was a standard way of developing applications, but as applications grew in size and complexity, this led to different challenges. First of all, the coordination between teams became more difficult because the code was much bigger and the parts of the application were more tangled into each other. Also, if suddenly you had a usage spike in shopping cart, for example, on holiday dates, and you would want to scale only that part of the application, you can't do it. You need to scale the whole application. This in turn means higher infrastructure costs and less flexibility in scaling your application up and down. Another issue is, for example, if a payment functionality used a third-party module with a version 1.8, while notifications feature needed the same module but required the version 1.7 instead. In a monolith application, you would have to pick one or the other because it's a single application and you can only have one dependency of the same module. Another major issue with monolith applications is that the release process of such applications takes longer because for changes in any part of the application, in any feature, you need to test and build the whole application to deploy those changes. And the answer to all these issues was a microservices architecture. So what is microservices exactly? With microservices, we break down the application in essentially multiple smaller applications. So we have several small or micro applications that make up this one big application. Now we have a couple of very important questions when we create a microservices architecture. First of all, how do we decide how to break down the application? What code goes where and how many such micro applications or microservices do we create? How big or small should these microservices be? And finally, how do these services then talk to each other? First of all, the best practice is to break down the application into components or into microservices based on the business functionalities and not technical functionalities. So the microservices of an online shop application will be products, shopping cart, user accounts, checkout, and so on, because all these are basically business features. And in terms of the size, each microservice must do just one isolated thing. So you shouldn't have a microservice that is responsible for shopping cart logic and the checkout. You should always strive to keep one service doing one specific job. And a very important characteristic of each microservice is that they should be self-contained and independent from each other. This means each service must be able to be developed, deployed, and scaled separately without any tight dependencies on any other services, even though they are part of the same application. And this is called loose coupling. So with this best practice approach, if you change something in the payment service, you will only build and deploy the payment service, nothing else will be affected. And this means the services have their own individual versions, which are not dependent on others. So if I release one service, I don't need to release any other service. So this release cycle has to be completely independent. Now, if these services are isolated and self-contained, how do they connect to each other? Because obviously the payment service will need something from the user account to process the payment, or the checkout service will need something from the shopping cart. Well, services in a microservices architecture most commonly communicate with each other via API calls. So each service has its own API, and the services make calls to each other on various API endpoints. And since they are isolated and talk to each other via API calls, you can even develop each service with a different programming language. And you can have dedicated teams for each service that can choose their own technology stack and work on their service without affecting or being affected by other service teams. And this is exactly the most important advantage of microservices architecture compared to the monolith. However, these benefits come with a price. So while microservices made developing and deploying applications easier in many aspects, it also introduced some other challenges that weren't there before. When you break down the application into these multiple pieces, this introduces a lot of complexities and challenges. One of the main complexities may be configuring the communication part between the services, because a microservice may be down or unhealthy and not responding yet, while another service starts sending requests to its API expecting a fulfilled response, in which case you may get unexpected results. Also, with microservices deployed and scaled separately, it may become difficult to keep an overview and find out when a microservice is down or which service is actually down when something in the application is not working properly. So you definitely need a proper configuration of your application setup and its pieces to make sure your application as a whole functions well. But there are various tools for making all this easier. So even though the microservices architecture is complex, there are a lot of tools and still more being developed regularly to make running microservices applications easier. Now, obviously, an important element of deploying microservices is a CI/CD pipeline. In fact, there are many companies with microservices applications that deploy multiple times a day. Companies like Amazon, Google, and Netflix, they have applications with hundreds of microservices that they deploy thousands of times per day. So you can imagine the complexity and the sophistication of their CI/CD pipelines. So in the modern world and workplace, you will be most probably working with microservices, and in this case, you would need to know how to configure release process with a CI/CD pipeline for microservices. And that's what we're going to learn in this part of the course. Now, we said microservices is when application components get developed and deployed separately as individual micro applications. So the question is, how do we manage the code for microservices application in a Git repository? Like GitLab, for example. With one project, it's simple. We just have one application and it gets its own Git repository. With microservices application, we have two options for how the code is managed. Monorepo, which stands for single repository, and polyrepo, also multi-repository. So monorepo or single repository is having one GitLab repository for all the services. So just like we created a GitLab project for our demo Node.js application for the previous chapters, we would create one project for a monorepo. So what's the difference here? Or how do we structure multiple micro applications inside one application repository? Well, a common way is using folders. So you have folders for each service, like shopping cart, payment, notifications, etc. And all the code for those services are in those respective folders. And having a monorepo, meaning all the services still in one repository, makes the code management and development easier because you only have to clone and work with one repository. So it simplifies things. Plus, if you have some shared code between the services, like Kubernetes manifest templates or Helm chart or Docker Compose, whatever, you can put them in the root of the project and all the services can basically reuse them. But monorepo also comes with some challenges. As I mentioned, the most important criterion of microservices is to be completely independent and isolated. So no tight coupling between the services inside the code. And it becomes easy to break this criterion when you have a monorepo. So you have junior developers with less experience in the monorepo setup. It's easier to make such mistakes and develop tightly coupled logic or code in your services. Another downside of monorepo is when the application becomes really big, cloning, fetching, and pushing becomes slow because your project is huge. And in terms of the CI/CD pipeline, specifically in GitLab CI/CD, you can only create one pipeline for a project. So you are building multiple services with a single project pipeline. And that means you need to add additional logic in your pipeline code that makes sure to only build and deploy the service which has changed. So if you make code changes in the payment service, your pipeline code should detect that, and only that service should be built, tested, and deployed. And it is possible to do that using GitLab CI/CD features, but it's a little bit more challenging. One more issue with a monorepo is that since you have just one main branch, because you have one repository, if developers of one of the services break the main branch, other services and their pipelines will be blocked as well. But there are a lot of companies, including very big ones like Google, who actually use monorepo for their applications. The second option, which is probably a bit more preferred one, is polyrepo or multiple repositories. With this approach, for each service, we create a separate Git project. So the code is completely isolated. You can clone and work on them separately because they are in separate repositories. Now, even though they are separate application repositories, they're still part of this bigger application. So of course, you would want to still have some kind of connection of these repos for an easy management and overview. So in GitLab, in addition to projects, you have groups. And if you remember, we learned briefly about groups in the GitLab runner section when we talked about the group runners. So essentially, you would create a GitLab repository group for your application called My Online Shop. And inside this group, you can create a separate project for each microservice that belongs to that application. If your company has multiple microservices applications, of course, this will help keep an overview of what projects belong together. But also within the group, you can actually create secrets or other CI variables that can be shared by all the projects in that group. And in addition, you can create runners that all the microservices projects can share. Now, what about the CI/CD pipeline for a polyrepo? Well, for polyrepo, the CI/CD configuration is more straightforward because you just have own pipeline for each repository. So no extra logic is needed to differentiate between the services. Now, of course, everything has advantages and disadvantages. So for polyrepo as well, you have some downsides. Like having application code in multiple repositories can make working on the project as a whole harder, especially if you need to change 2 or more services at once because a feature or a bug fix affects multiple services. If you need to switch between the services often, this can also be tedious. Plus, things like searching something across multiple projects from the code editor can be difficult or impossible. Also, in the polyrepo, you can't really share files in the project like Kubernetes or Helm manifests, Docker, Compose, and so on. You would either have to duplicate them in each project's repository or have to create a dedicated project and reference them from there. So as you see, both options have their advantages and disadvantages, but the general rule is that if you have a small project with just several microservices, you should stick to monorepo and save the overhead of creating and managing and checking out multiple repositories. On the other hand, if you have separate teams for each service, if you want to have complete isolation, smaller code base to clone, own pipelines, and so on, then of course the polyrepo would be a better option. And in this course, we're going to actually see both of these options and how to work with them. So now that we know what microservices are and different repository strategies for them, let's actually see all that in action. I have created a simple microservices application made up of 3 services. The front-end service, which is the UI of the application, and 2 backend services. We have the shopping cart and product service. All 3 services are written in Node.js for simplicity, which is actually pretty common for small microservices projects where you have one team of developers that develop all the services, so they stick to one technology stack. I also created a monorepo for this demo microservice application, so we will see how to configure a CI/CD pipeline for a monorepo project. We will build a similar pipeline as for our demo Node.js project, in which we will build and deploy each service to an EC2 server using Docker Compose. After that, we will create a polyrepo for the same project and build the same CI/CD pipeline for our polyrepo application. And along the way, of course, we will see the comparison of these two and also learn important concepts of reusing the pipeline configuration for multiple services in both monorepo and polyrepo setups. So let's get started. So this is my monorepo for the microservices application. I've called it my microservice-CI/CD. So this is one project and all the services are organized in folders. So we have a front-end folder, products, shopping cart. And all the code and configuration for each microservice is in those respective folders. So all the code that a front-end service needs to start the application, to install the dependencies, to build the Docker image, everything is in that folder. And the same applies to shopping cart and product service. So let's actually clone this application locally and see a little bit of what's inside the code and how these services actually talk to each other. And then we're going to start all these 3 services locally and see the functionalities of all 3 in the browser. So let's grab the clone URL and let's do git clone the project. So that's the name. And in the Visual Studio Code, let's open our project. And as I showed you, each service folder contains everything that the service needs to be built and to be started and so on. So frontend has the index.html because we need some UI, and it has the server.js, which basically starts the application, serves the index.html, and then handles some button clicks. And frontend talks to products and shopping cart services. And the communication is happening very simply using HTTP requests, right? So the frontend server.js will make a call to get products. So the products API or the products endpoint on the port where the product service is running and basically send an HTTP request. And the same way it will make a call to the shopping cart on the shopping cart endpoint on the port where the shopping cart service is running. And in the products, we have a server.js that will receive and handle these requests. So we have this function that basically accepts the request coming on the endpoint and send some response back to the front end. And we are starting the product service on port 3001 and the shopping cart service on port 3002. So each one has its own endpoint on port. They're running separately, and frontend talks to products and shopping cart services when we click a button, right? When we can trigger this communication in the UI. And also each one has its own Docker file that starts the service on the specified port, like this. Pretty much similar logic for each service. So this is a very simple application. The code is very simple, and the important thing is that each service is programmed in a way that it can be run, it can be built completely isolated from other services independently. So there is no code dependencies between them. They just talk to each other on the API. So now let's see how we can start the application, or basically all the services of the application, one by one. So I'm going to open the terminal. And let's make it a little bigger. So basically, I'm in the root directory now. And we can start any service in any order. So we can start the products first, and then front end, shopping cart, it doesn't really matter. They can be started separately. But in our case, let's go to front end first, so we can see the UI right away. So let's go to front end, and here we have the package JSON, which contains the dependencies. So first, let's install those dependencies. And now let's do npm start, and this will start the front end on port 3000. So products and shopping cart services are not running at this point, only front end is. So now let's go to browser and access the front end service on port 3000. And this is what front end service displays. It has this index.html that we saw that basically shows this UI that we see here. And we have 2 buttons, and each one will send a request to the corresponding backend service. So this one will send a request to products, this one will send a request to shopping cart. And the best practice would be that if products is not running and if I click on the button, you basically handle that error and application continues running, it doesn't crash. Because again, one microservice being down shouldn't affect the whole application and shouldn't crash everything. In my case, I haven't added that error handling, so if I basically click on these buttons, nothing happens, but the front-end application will crash. So that will be additional optimization for a microservices application to have this error handling. So let's start the front-end again, refresh, and now let's start other 2 services. So I'm going to create a new terminal. So the front end is still running. And in this one, let's see where we are. So let's go to products, do npm install, and npm start. So products is running on 3001. So our front end, when we click on the button, on the view button, will send a request to the product service on port 3000 in the background, right? So it's going to happen in the code. So let's go ahead and click on it. And as you see, we got a response from the product service with some data that we're displaying here. And we can see that in the logs of the front end as well, where we received the response from product service. Now let's go and start shopping cart as well. npm install and npm start. This one is running on port 3002. And if I click on view, again, in the background, front end, the server.js basically sent a request to shopping cart at port 3002, and it received the response from the shopping cart service, and we're displaying that response here. And we can also see that in the logs of the front end. So that's how the application works, basically. Very simple, very straightforward. As I said, additional optimization would be handling the view button click when the service is not available. So that's our application. And now we want to create a release process or CI/CD pipeline for all three services in our application. Now we want to build a CI/CD pipeline for this project. Let's do a couple of things to prepare for it. First of all, we need to configure GitLab runners for our project. So if I go to the GitLab project of microservice monorepo in CI/CD settings and expand the runners, you will see that we have no specific runners registered. And just like we did for other projects, we will have to register our own specific runners for this project. Or we could also use the shared runners. Well, we already have runners that we created and registered for the other project, and it is possible to share the runners between the projects. So we could add additional runners and register them with this project specifically, or we could share or reuse the one that we use for another project. So let's go ahead and do that to also showcase how this can be done. So let's open my Node app project, and in the settings, runners, we have these three runners. One of them is with Docker executor, another with shell executor, and let's actually reuse this one. This is with the shell executor and has Docker installed in it. And we need Docker command, so let's go with this one. If I click on the edit button here, we have a couple of settings that we could change, and one of them is a check mark that says lock to current projects. So this one is basically locked to be used only for that specific project that we assigned it to, but we can unlock it and then we will be able to use it for other projects. So I'm gonna uncheck this and save. And now if I refresh this and expand, you see that this one appeared as available runner, and we can enable this now for our project. So I'm gonna click on this and there you go. So we're using the same runner for two projects. So the specific runners, because they're always assigned to the project, by default, they will be locked to the project. So we'll have to unlock it and then you'll be able to reuse it in other projects. Of course, if you have permission to do it. And you also see that lock icon disappeared once we unlocked the usage of this runner. Cool, so we have a runner that's taken care of. If we needed a Docker executor for this project, then we could also unlock the other runner that has Docker executor on it. Now as a next step, we would need a deployment server for this project to deploy all our services. And I already deleted the deployment server for the demo Node.js project. So in this case, we're going to create a new server. We're going to install Docker and Docker Compose on it, and we're going to save the SSH private key to access it. So let's go ahead and do all of that to prepare our deployment server. So let's go to our AWS, do launch instance. we're gonna start an Ubuntu server. That's the version we're gonna use, 20.04. We're gonna leave everything else, which is selected by default. You probably also noticed the UI of the AWS changed a little bit from the previous demo because AWS updated their UI. So looks a little bit different. Right here we have the key pair selection. Usually this option was configured at the end of creating the instance. Now we have it right here in the configuration. So let's actually go ahead and create a new key pair for our server, and let's call it microservice deployment server. Okay, it's a little bit long name, but whatever. So let's do create key pair. This will download the PEM file. So we have an SSH key to be able to SSH into our server. Again, network settings, we're gonna leave everything as selected by default. One instance, and let's launch it. And while our instance is initializing, let's actually go ahead and change or restrict the permission of our SSH key so we can use it to SSH into the server. So I'm gonna open a new terminal here, and let's do change mod 400, and in the downloads we called it microservice deployment server key. So let's execute, and let's prepare the SSH command. So that's the key, Ubuntu user, and we're gonna grab the public IP of the instance, which is right here. Execute, and we're inside the server. Now, as I said, we need to install Docker and Docker Compose here because we're gonna be running Docker containers. So let's go ahead and do that. Let's first do sudo apt update because we are on a fresh new server, so we need to update the repositories. And now let's install Docker using the suggested command. There you go. Now let's install Docker Compose. And finally, if you remember, we need to make Ubuntu user able to execute Docker commands without sudo to avoid the permission denied issue. So we're gonna do sudo user mod -ag, so add group, Docker, the current user, right? So we are adding the Ubuntu user to Docker group. And now if I exit and log in again, do docker ps, there you go. No permission denied anymore. Everything is set up on our deployment environment. Now let's go ahead and create our pipeline configuration that will build the Docker images of our services and deploy them here on the development server.